All right, you guys, what's up? Let's go ahead and review some calculus. We're going to start today with the Unit 1 review, going back to the beginning. Okay. Let f be a function that's continuous on the closed interval. This is important. The fact that it's continuous is usually what we need for almost all of these theorems, okay? F of 2 is 10. F of 4 is 20. Which of the following is guaranteed by the intermediate value theorem? Let's think about this one, okay? This is on your flashcards, guys. Now you know that if, I don't know, I kind of just like to draw these just to get an idea of, what I'm doing. If that's the point 210 and that's the point 420, think about this. What it's saying is that in order to go from here to here, it basically has to hit every point in between there. It has to hit every point between 10 and 20 somewhere with an x between 2 and 4. Okay? So let's read through these. F of x equals 13 has at least one solution. Does it have to equal 13 in there somewhere? That sounds pretty good. Does f of 3 exactly have to equal 15? We definitely don't know that. All right. Does f attain a maximum on the open interval? You guys, this is actually a different theorem. We haven't used it a ton, but this is called extreme value theorem, which says that if a function is continuous on a closed interval, there has to be a maximum and there has to be a minimum. It just says it has to exist, right? There has to be a high point and a low point, okay? But that's extreme value theorem. F prime of x has at least one solution in the open interval. That's actually mean value theorem, and I'm going to review this with you really quickly. Whenever we're kind of looking at an F prime question, a lot of times mean value theorem comes up with something where it's like derivative equals slope, okay? And if you look at the slope of this, 20 minus 10 over 4 minus 2, that's 10 over 2, which is 5. And so somewhere the derivative is going to equal 5. This is the definition of mean value theorem. Okay, and then finally, let's just kind of read through this last one. This is saying f prime of x equals 0 for all x. So what does that mean, you guys? It means derivative is positive, which means the slopes are positive, which means f is increasing. I mean, we might think that f is increasing, but I mean, no, like the thing I drew right there shows it could be increasing, decreasing, like we have no idea. Okay, so like none of these are true. Those all do tell me different things about certain graphs, but this graph, the answer, or this question, the answer is going to be A. All right, let's look at number 2. We've seen on our questions, on our review questions, a few limits questions. Let's check it out. If the limit exists and f is not continuous, then b equals. Oh, and we have some multiple choice answers over here. Okay. All right, let's see here. Let's look at places where the limit does or does not exist. Let's look at places where it is or it is not continuous. Okay. Okay, look, this place right here, I'm going to say the limit does not exist. All right, and the reason that the limit does not exist right there is because the two sides are pointing in different directions. Also, right here at this spot, it's also not continuous. Okay, so the limit exists and it is continuous. So no, absolutely not. Okay, let's look at this spot right here. Right here, the limit exists. You guys remember, both sides come together. That's the limit existing. So limit exists, but it's not continuous. Let's see. Oh, that could be it right here. The limit exists, but is not continuous. Limit exists, f is not continuous. So it could definitely be that one. Okay, let me look at a different one. The limit exists right here, and it is continuous. The limit exists and f is not continuous. So it's not that one. Right here, the limit doesn't exist. And it's not continuous. And then everywhere else the limit exists, right? So those are the only interesting points. So this like orange kind of point right here that I highlighted there, the limit exists, but it's not continuous, okay? Now at 0, let's make a couple of statements real quick, and then I'm going to see what this question is asking me for. The limit as x approaches 0 of this function is 2, because that's where the limit goes to, all right? The two sides go to that. But it's not continuous because the point is at 1. All right? So what does it say? limit as x approaches b exists. F is not continuous at b. B equals. Okay, so it's actually asking me for b, though. It asks me what point that happens at, and that happens at 0. All right, making sure you know the definitions of limits and continuity. Okay, let f be a function that is differentiable on the open interval. You guys, differentiable also means continuous. Okay, so it means both. We have an open interval, 1 to 10. There's a thing about this real quick. Okay. F of 2 is -5. F of 5 is +5. And F of 9 is back to -5. I have a feeling that's going to ask me about some theorems and stuff. But the first thing I'm noticing, right? Let's see, this is the axis. It's going to be crossing over and then it's coming down again. Okay. Does F have at least 2 zeros? So let's take a look at this. If I have to make it up to that point and down to that point, right? Can you guys see that, no matter how I draw this, I mean, if I do it very simply, fine, that's 2 zeros. Or I could even go kind of crazy like this. And it could have 6 zeros or whatever. Anyways, does it have at least 2 zeros? I'm going to say that's definitely true because it has to get up there and get back down there again, right? I like to draw a lot of these things. Kind of helps me out. Okay. The graph has at least one horizontal tangent. All right, let's think about this. A horizontal tangent is a point where the derivative equals 0. All right, let's think about what horizontal tangent means. A horizontal tangent is a point where the derivative equals 0. And not only does the derivative equal 0, but it changes, specifically from positive to negative or negative to positive. It's like a max or a min. Does it have to have one? Yes, as long as it's continuous and differentiable. Okay, check this out. In order for it to not have one, let me draw something real quick. Like this does not have a horizontal tangent, okay? Mm-hmm. Except this is not differentiable everywhere. Continuous and differentiable means smooth. It means I'm coming through here smooth. There has to be a horizontal tangent somewhere. I'm going to go ahead and go with true on that one. Okay. Okay, my last one says that for some number in between 2 and 5, f of c has to equal 3. Let's see here. Is there a number where this has to equal 3? So a y value of 3 would be up there. I mean, yeah, if it's getting up to 5, it has to equal 3 somewhere between, let's see, between 2 and 5. Yeah, it does, because it's going from -5 to +5. That, you guys, is intermediate value theorem. Okay, so that's also true. So I'm going to go ahead and say that all of the above are true. Alrighty, moving on to number 4. This is a calculator question. On these little reviews, when you see that, that means it's a calculator question. So I'll show you guys. I have a calculator I can pull up and then we can look at. All right. The graph of the function is shown in the figure above. The value of the limit as x approaches 1 of sine of the function is. Well, first let's figure out what's the limit as x approaches 1 of the function. All right. As I'm approaching 1, what's the limit? The limit is 2, okay? So as I'm approaching 1, the limit's going to be 2. So now I'm really just kind of looking for what is the sine of 2, all right? Now on my calculator, the first thing is we got to make sure that we are in radian mode, and we'll check that before you guys start the test, right? Okay, so I'm in radian mode, and then I'm just going to go sine of 2. It's that's weird, but it's just a radian of 2. So I got 0.909, okay? All right, so that's just making sure you know how to use your calculator there. Okay. If the limit as x approaches 3 of the function equals 7, which of the following must be true? Okay. Step 1. Does it have to be continuous? Do you guys think that this has to be continuous? If the limit exists, does it mean it has to be continuous? Absolutely not. There you go. Not continuous. But the limit exists. So does that have to be true? No, that's false. Does it have to be differentiable? Well, let's remember that, if it's not continuous at that point, it can't be differentiable at that point. Also, something like this Okay, the limit exists, but it's not differentiable right there, right? So that does not have to be true. If the limit goes to 7, does the point have to be at 7? Remember, this means point. If the limit goes to 7, does the point have to be at 7? No, we've seen stuff like that where the limit goes to 7 and the point is at 10. That also does not have to be true. Okay, so we've got none of the above are true. All right, and let's look at number 6. Okay. Oh, these are fun. Okay, you guys, when you have a piecewise function, right, this is like this with two different things, we want to know if it's continuous and or differentiable, all right? The way we're going to check continuous is we're going to take the original equations, right? There we go. The original equations, we're going to plug in 3. If those are equal, they're continuous. Then we're going to take the derivative of each, and we're going to plug in 3 and see if they equal each other, then they're differentiable. So this one will tell me continuous. This one will tell me differentiable, okay? Let's go ahead and plug this in. Into the top, when I plug 3 into x squared, I get 9. Into the bottom, when I plug 3 into 6x minus 9, I get 18 minus 9, which is 9. Okay, look, those are the same. So this is continuous, right? Now let's go down here. Let's take the derivative of each one. Not that I've necessarily seen it written like this, but it makes sense to me. So the derivative of x squared is 2x when x is less than 3. The derivative of 6x minus 9 is 6 when x is greater than or equal to 3. All right. And now if I plug these in, if I plug that into 2x, that's going to give me 6. If I plug that in, well, that's just a constant. That's going to give me 6. Those are the same. So it's not only continuous, but it's differentiable as well. So I can go ahead and pick continuous and differentiable. Okay? And that looks like that's it for our multiple choice questions. Let's look at a couple of free response here. All right, so taking a look here at number 7, this just kind of tells us about how to simplify, blah, blah, blah. They don't need to be simplified. This is our rule for free response questions right here. All right. 3 decimal places. Okay. Blah, blah, blah. Okay, here we go. All right, I'm going to go ahead and mark the stuff that's important here. Functions f, g, and h are twice differentiable, so they're differentiable, they're continuous, that. That means that at x, g, and h both equal 2. That line is a tangent line to the graphs of g and h at 2. Okay? Find h prime of 2. Well, look, if this is a tangent line, now you guys, I actually write this a different way, right? I usually will write it like this. Y minus 4 equals 2/3 x minus 2. Like, that's how we write it. A lot of times I've noticed on, the AP answers and stuff, it puts the 4 over there, which is fine. What does that mean if that's a tangent line, okay? Now, it's a tangent line for both g and h. Right now I'm talking about h, but what does that mean? It means that when x was 2, the h value at that point was 4, which we can verify right there. And what does that mean? That means that the derivative was 2/3. That's the slope. So it's almost like giving us the answer instead of making us find all the parts, giving us the answer and making us identify each part. Well, h prime of 2 is going to be 2/3. Okay, that's our answer for the first one. Okay, for part B, let a be the function given by this. Write an expression for a prime. Find a prime of 2. Okay. Let me actually see if I can get rid of this and write over it. Oh, look at that. All right. Okay, if that's a, and I need to write a prime. Now it's weird because it has this h of x in there, and we don't actually know what h of x is, but we know that this is a, sorry, that looked like a decimal point. We know that this is a product, okay? So I actually have a product rule right here. Oh, shoot. I erased it. Okay. I've actually got a product rule right here, right? Do that right now. There we go. Okay, here we go, guys. A prime equals the derivative of the first times the second plus first times derivative of the second, okay? Now, for the derivative of the second, I just have to put h prime because I don't really know what it is. But, all right, derivative of the first, 3 times 3 is 9x squared times the second. and then 3x squared times h prime. So write an expression for a prime of x, did that. Find a prime of 2. Well, this is going to be 9 times 2 squared, and then h of 2. Okay, I'll come back to that in a minute. 3 times 2 squared, and then h prime of 2. Okay, so check this out. 2 squared is 4 times 9, that's 36. What's h of 2? It would have told me somewhere else in the problem. And here it is right here. H of 2 is 4. Okay, 3 times 2 squared, that's 12. And then it's h prime of 2. It would have been somewhere. There it is. It was the answer for part A is 2/3. All right, so let's go ahead and calculate this now. 36 times 4. Oh my goodness, when they make me do this without a calculator. Let's see. That's 120 and 24, so that's 144. Okay, here it's like 3 goes into 12 4 times, so that's 8. Oops. There we go. So that's 8. So that equals 152. Okay. All right, cool. Let's read this next one. Let me get rid of this and this for C and D. We should have just whited that out before we made copies. Okay. The function h satisfies that for x is not equal to. The limit as x approaches 2 of h of x can be evaluated using L'Hopital's rule. Use that limit to find f of 2 and f prime of 2. Like what? It's like, almost like kind of like right now I can't really understand what this is saying, but I did see one thing, and that says L'Hopital's rule. So I'm like, all right, let's go. Well, first let's think about this real quick. Oh, and we're doing, I should write it like this actually. I should write the limit. Let's just write it out here. Limit as x approaches 2 of that equals, boom. Okay. Guys, the first thing that I wanted to remind you is we are only allowed to use L'Hopital's rule when this equals 0 over 0 or infinity over infinity. Those are like, it's a restriction. You're not allowed to use L'Hopital's rule if it's like 4 over 5. You just can't do that, right? So what that means is, okay, if I take 2 and I plug it in the top, okay, so sure enough, I get 0, which means if I plug 2 in the bottom, I should get 0 also. Like that's just a criteria before I even do the problem. So what that means is 1 minus f of 2 to the third will need to equal 0. Can I do something with that? Like I feel like I can, right? Subtract the 1 over. Divide by a negative. Take the cube root of it. F of 2 is 1. So that's cool, but that's just satisfying the condition, right? Now I'm actually going to do L'Hopital's rule. Okay, so check this out. Limit as x approaches 2 of the derivative is going to be, okay, let me start with derivative of the top. Now the derivative of x squared minus 4 is 2x. The derivative of the bottom. Okay, check this out, you guys. 1 goes away because that's a constant. All right, I still do have, sorry, let me get that out of there. There you go. Okay, so that's going to go away. But I still have to do, and let me actually, sorry, this is getting in my way, that little 2 right there. Oh gosh, never mind, I won't erase it. Okay, so let me also say that now when we do the derivative of the bottom, there's still negative in front of here, right? You guys got to do the chain rule. Negative 3 f of x squared, and then times the derivative of that, which is f prime of x. Okay? The function satisfies. It's known that the limit can be evaluated. All right, well, let's see here. I know as I find the limit of h prime as x approaches 2. So if x is approaching 2, okay, on the top, this is going to give me 4. On the bottom, this is going to give me negative 3. This is going to give me f of 2 squared. But f of 2 is over here. So, well, I'll write it right now. F of 2 squared and then f prime of 2. All right? So let's see here. I gotta move this over, you guys. You want me to move that over? Ah, beautiful. Okay, very cool, very cool. All right, so now let's take this. This is gonna be 4 over negative 3. F of 2 was 1 squared and f prime of 2. All right. Now, I know that can be evaluated. Use the limit to find that and that. H, oh, and because it's twice differentiable, which means it's continuous, h of 2 is supposed to equal 4. Because it is continuous, you guys, the limit as x approaches 2 should also equal 4. That's what's going to make it continuous, is the limit and the point should equal each other. So that should equal 4. Okay, in order for that to equal 4, the bottom has to equal 1. Does that make sense? Like 4 over 1. So I'm going to work on the bottom now. I'm going to say, okay, negative 3 times 1 squared, f prime of 2 has to equal 1 for this to work out. So f prime of 2 has to equal negative 1/3. Woo, that was a crazy one. I liked it, but it was crazy. All right, those are your answers for that part. Okay? All right, for part D, you guys, I'll be honest with you, this is not something I've really taught you. If it shows up, it shows up so rarely. It's called the Squeeze Theorem. And, you know, I went ahead and put it on your flashcards. We just didn't have this time this year to like cover everything. You know what I'm saying? Let me show you really quickly what the Squeeze Theorem says. Okay. So it's like right here. If you guys can see this, let me try to scroll it in a little bit, make that a little bigger. Because G and H are continuous and differentiable. The limit as G approaches 2 is 2. G of 2 is 4. We were told that. The limit as H approaches, as X approaches 2 of H equals H of 2 equals 4. Because K is in between, it follows from the Squeeze Theorem that should also equal 4. And K of 2 equals 4. All right. So it's basically saying, let's see if I can state this for you in a like different way here. All right. It's basically saying if that one has a limit of 4, and that one has a limit of 4, then K has to have a limit of 4. And if G of 2 is less than or equal to K of 2 is less than or equal to H of 2, and if that's 4 and that's 4, then K of 2 has to equal 4, and therefore it's continuous. But just think about it like squeezing together. So not one we've done a ton, but kind of glad that one showed up there. Okay. All right, let's take a look at number 8. Ooh, we got this awesome graph here. Let me go ahead and get rid of all this space that we don't need. We got this graph, and then we have like a 4-part question. Okay. Okay, cool. And that's it. All right, here we go. Show your work, blah, blah, blah. Clear label functions. This is all directions. All right, cool. Here's my graph. Let's check this out. The continuous function f is defined on the closed interval -6 to 5. This shows part of f. It shows -2 to 5. F actually goes all the way over to -6, so we should probably remember that. 2 line segments and a quarter circle. This tells me I'm going to be doing some geometry in a minute here. Centered at the point 5, 3. Okay? So there's like this, you guys can see that like this circle. All right. It is known that the point 3, 3 minus root 5 is on the graph of f. So that point is 3, 3 minus root 5. That is that point right there. Okay. All right, here we go. This, I think it just didn't print. These are supposed to be like dx's. I don't know why it didn't print that. If the integral from -6 to 5 is 7, find the integral of -6 to 2. Okay, you guys, I can make a statement. Now, you know how we would sometimes do it like this. And we go, like if I put it in order, okay, -6 to 2, -2 to 5, and then what's the whole thing? All right, this one says the whole thing, -6 to 5 is 7. This one says -6 to -2 is what I'm looking for. And so what I need to find from my graph is probably -2 to 5. Okay. So I'm looking for the integral there. So the integral from -2 to 5, okay, I could calculate this. I'm going to start with this part. And then actually this part, well, no, I won't do it that way. I'd say those are going to cancel each other out, but let's just do this. Okay, this part is a triangle, so that's 1/2 base height, so that's 0.5. Let me just say 0.5. This, I'm going to do the whole thing. Does that cross it? Okay, hold on. Up 1, 2, 3, 4 over 2. So it crosses halfway there. Okay. Sure, let's do this. Okay, this is 1/2. The base is 1.5. The height is 1. So this is 3/4 or 0.75. Because it's on the bottom, I got to put a negative right there. All right. I got to do this section and then this section. Okay. One thing at a time here. Not getting overwhelmed. Here we go. Boom, boom. Okay, this section, that goes from 0.5 to 2, so that's 1/2. The base is 1.5. Or, I mean, I probably should have used, well, no, it's fine. I was going to say 3 over 2. I've been using fractions, but, and the height is 3. Okay, half of 3 is 1.5. 1.5 times 1.5 is 2.25. Jeez Louise. All right, now this last one, you guys, I have to find this area. Okay, that's a little weird because it's like the outside part of a circle, but check out how I'm going to do this, okay? This entire thing right here is base 3, height 3. So that rectangle is 9, right? I should move that to the outside, actually. That rectangle is 9. Now, this is a quarter of a circle, and the circle has a radius of 3, so it's 1/4 pi 3 squared. So it's 9/4 pi. So this little extra part right here, you guys, is going to be 9 minus 9/4 pi. Okay? Whew. All right, so I'm going back over to here. And all right, let me just say that the integral from -2 to 5 is 0.5 minus 0.75 plus 2.25 plus 9 minus 9 over 4 pi. Okay, oh, for goodness sakes. All right, that's -0.25 and plus 2.25, so that's all just 2. 2 plus 9 is 11 minus 9/4 pi. Not done with my answer yet, you guys. That is what this is. 11 plus 9/4 pi. Okay? Now, my statement right here says x plus 11 plus 9/4 pi equals the total integral. So to solve for x, x is going to be 7 minus 11 minus 9/4 pi. So x is going to be -4 minus 9/4 pi. And that's what the integral that we were looking for from -6 to 2 of f of x is. All right. Sorry, guys. I just realized I made a tiny mistake. Over here it says 11 minus 9/4 pi. Over here, I changed that to 11 plus 9/4 pi. What was I thinking? That's minus, which means that that was minus, which means that that should be plus. Okay, so my bad. That's plus 9/4 pi. Shows you how easily you can make a tiny error. Luckily, you still get most of the points on that problem. Okay? All right, sweet. Let's look at part B. Evaluate the integral of 2f prime of x plus 4 dx. Okay, you guys, integrals. First thing it says is I could split these up. 3 to 5, 2 of f prime of x. And the integral of 3 to 5 of 4. These should both have a dx on them. Okay? Why do my 3 and my 5 look the same? Oh, shoot. Come on now. 3 to 5. Okay? All right. Also, constants, I'm allowed to move out in front. Now, you guys, what's the integral of f prime? So think about this. The integral of a derivative is just f, evaluated from 5 to 3. Over here, the integral of 4 is 4x, evaluated from 5 to 3. Okay? Now, this first part right here, I'll bring this over here. It's going to be 2. And then it's going to be basically f of 5 minus f of 3. Okay? So figure that out in just 1 second. On this other side, this is going to be basically 20 minus 12. All right. Now, how am I going to find f of 5 and f of 3? Well, if I look, this is the graph of f. So f of 5 is that point right there, which is 0. F of 3 is that point right there, which luckily they gave it to me so I don't have to find it with, the equation of the circle and stuff. Okay, so f of 5 is 0. F of 3 is 3 minus root 5. Okay. 0 minus 3 minus square root 5 plus 8. If I distribute that negative, that'll be negative 3 plus root 5 plus 8. So that's going to be negative 6 plus 2 root 5 plus 8, which is going to give me 2 plus 2 root 5. All right? So I got 2 plus 2 root 5. All right, you guys. Part C is something I really wish we'd spend a little bit more time on, but I will tell you this is kind of important. We didn't spend a ton of time on it. I'm going to try to this upcoming week. Okay, but we got to talk about how to maximize G, where G is actually an integral. And it's like, what the heck? We got to go back to our definitions, okay? We got to go back to our definitions. In order to find an absolute max, we have to check endpoints and critical points. Okay, we have to check endpoints and critical points. Now, the endpoints, well, look, those are given to me right here. Okay, so my endpoints are at -2 and 5. How do I find my critical points? Okay, let's think about this. We're finding critical points of G. And the way that we find that is critical points are when the derivative equals 0. So let's take this and let's take a derivative. Well, remember, when we take the derivative of that, we take the derivative of this, and it's that second fundamental theorem of calculus, which says a derivative and an integral cancel each other out. So the derivative just equals f of x. If I'm trying to find where the derivative equals 0, that's where f of x equals 0. So going back to my graph, where does f equal 0? Well, how about right here at -1? How about right here at 1/2? And how about right here at 5? So my critical points are -1, 1/2, and 5. Okay? This is going to get you a couple of points right here, at least just like identifying those. All right? Checking my endpoints, checking my critical points, identifying all of them. Okay? Now, at this point, we could make a signed line graph, or we could just evaluate them. And I'm just going to go ahead and evaluate them. You guys, sometimes I like to keep my data nice and organized by doing this. So -2, I'm going from smallest to largest, that's an endpoint. 5, that's an endpoint. So -1 and 1/2 are in the middle. Okay? Now, y is g of x. We're plugging this into g of x. Coming back up here, g of x is an integral. Okay? So here we go. I'm going to need to take some room for this guy here. All right. G of -2 is, okay, I'm going right into here, the integral from -2 to -2 of f of t dt. Well, you guys, anytime I have an integral of a number to itself, that's 0. Okay? G of -1 is the integral from -2 to 1 of f of t dt. Luckily, when I was doing this before, I marked it all down. The integral from -2 to, -1, right? -2 to -1 is 0.5. I marked that down. Okay? G of 1/2 is the integral from -2 to 1/2 of f of t dt. Okay, -2 to 1/2 means here to here. That's 0.5 minus 7.5. You see, guys, where I'm getting that? So that's -2.5. -0.25, sorry. And then g of 5 is the integral from -2 to 5 of f of t dt. Guess what? I'm not going to calculate that again. I already found it. The integral from -2 to 5 was that, 11 minus 9 pi over 4. Okay? And I want to know the absolute max. Okie dokie. It's definitely not that. It's definitely not that because that's small. It's definitely not that. Shoot, I guess my only question is 11 minus 9 pi over 4. Gosh dang, is that a positive, a negative? What is that? I have to kind of compare it to 0.5. Huh, let's think. If I estimate that as like 3.14, but let's say I do 3, and that's like 27 over 4, maybe 28 over 4 because 3 point, right? 28 over 4 is 7, so 11 minus 7 is positive 4. Hey, there we go. So I have an absolute max of 11 minus 9 pi over 4, and it occurs at x equals 5. That's my absolute max. All right, it's probably just asking for the 11 minus 9 pi over 4. Last question, here we go. The limit as x approaches 1, okay? Remember, you guys, what we do is we always start by just plugging it in first. Numerical limits, we plug it in. So this is going to give me 10 to the 1 minus 3 times f prime of 1. This is going to give me f of 1 minus arctan of 1. Okay, so there's a few things we got to talk about here. We got to talk about f prime of 1. I forgot I can't highlight over the stuff that I've whited out. Okay, and I got to find that. All right. Now, f of 1 and f prime of 1 can come off my graph. Let's go take a look. This is the graph of f. F of 1 is the value at 1. That's 1, 1. F prime of 1 is the slope at that point. Okay, now this slope goes up 4 over 2. So the slope is positive 2. Okay, so like 1, 1 is the point. 2 is the slope. So f of 1 is 1. F prime of 1 is 2. I got that off my graph. Now I need to figure out what arctan of 1 is. Remember, sometimes we write it as inverse tan. You guys, you know your best friend chart? We love our best friend chart. We have this whole green chart that you can't take on the AP test day, so you're going to have to make it. Sine, cosine, tangent. Show you how fast I can make this, though. 30, 45, 60, pi 6, pi 4, pi 3. This is 1 over 2, root 2 over 2, root 3 over 2, root 3 over 2, root 2 over 2, 1 over 2, 1 over root 3, 1 root 3. Okay, what this means is what angle does tangent equal 1? Look, tangent equals 1 right here. At what angle? Pi over 4. So the inverse stuff, you guys, is going backwards on your chart. So the arctan of 1 is pi over 4. So check out what my answer is going to be here, okay? 10 minus 3 times 2 over 1 minus pi over 4. 10 minus 6 is 4. I'm just going to call this 4 over 1 minus pi over 4. Okay? Fair enough? And there we go. That's the end of review 1. Thanks for tuning in.